When the $10 billion device trained its infrared vision on the exoplanet K2-18b, 120 light-years away, it detected dimethyl sulfide, a sulfur compound that, on Earth, is produced exclusively by organisms. Does this mean that the matter is settled? Can we finally answer the oldest question of mankind? Whether we are really alone in the universe, with a clear no? Well, that is precisely the crux of the astronomical debate. While one side of the experts is already popping the champagne corks, the other side is calling for a little more patience and pointing out that even the capabilities of the most powerful space telescope of all time are limited. Hand on heart, in most people's daily lives, dimethyl sulfide, or DMS for short, probably plays no significant role. In fact, most people have probably never even heard of this particular chemical compound, even though they have very likely encountered it at one time or another. In detail, DMS is formed by microscopic algae, the phytoplankton, which drift in the uppermost layers of the ocean, and it is responsible for the typical smell that we notice when we are at the beach. Apart from its sniffing properties, DMS also has another important characteristic. So far, we only know of biological sources for this sulfur compound, and where the production of a substance requires the help of organisms, it is understandable that DMS plays a very special role in the search for extraterrestrial life. It is even more understandable at the cries of joy that came from the lips of the Cambridge astronomers in September 2023. After all, the James Webb Telescope had detected nothing less than this potential biosignature on the exoplanet K2-18b. The overwhelmed discoverer, Niku Madhusudhan, then told the press that he and his colleagues were completely shocked by their readings. No wonder, because, after all, the existence of DMS in the vastness of space is nothing less than a serious indication of extraterrestrial life. What initially came as a shock to the experts soon developed into almost euphoric reporting, which unceremoniously elevated the James Webb Telescope to the key to the cosmic search for life. But is the matter really as clear-cut as it seems? If the corresponding molecule on Earth is only produced by living things, and we then discover it on an alien body, why hasn't NASA officially announced that our microscopic neighbors are slumbering on K2-18b? Well, that's because, as so often, the devil is in the details. But basically, the conditions in the case of K2-18b are anything but bad. Is the water world a haven for life? Located about 120 light-years from us in the constellation Leo, the celestial body is under the exciting suspicion of being a Hycean planet. In other words, a planet whose surface is completely covered with water and can therefore support life. And while K2-18b was added to the star charts in 2015 with the help of the Kepler Space Telescope, it orbits its central star, the red dwarf K2-18, within the habitable zone. This, in turn, describes the distance range at which a planet must be located in relation to its host star for water to be able to exist there in a permanently liquid form. As we all know, the cool, wet element is considered one of the fundamental pillars for the development of life similar to that on Earth. And although K2-18 is significantly cooler than the Sun, its planetary companion receives roughly the same radiation as our Earth due to the given constellation. The bottom line is that K2-18b is only 0.14 astronomical units away from its parent star, so that it takes just 33 days for a complete orbit. And indeed, the pro column on this life discussion list also contains the entries methane and carbon dioxide, and thus two further indicators that suggest we may actually be dealing with a habitable planet here. If this is really the case, it would be a cosmic novelty because, so far, these exotic water worlds only exist on paper. But while the detected large amounts of methane and carbon dioxide, in combination with the lack of ammonia, suggests that K218b is a Neptune-like planet covered by liquid water, the detected substances also present an unfortunate complication. They make it all the more difficult to interpret the DMS data correctly. The mystery of the biosignature is intriguing. In principle, the DMS signal was anything but pronounced in the collected datasets, and it only revealed itself when the data was analyzed in a very specific way. The matter was not made any less complicated by the fact that the DMS signature identified by Webb's near-infrared spectrometer, NIR spec, appeared in a spectral line at a wavelength of 3.4 micrometers, precisely the range that overlapped with methane. That is the crux of the matter, as scientists believe distinguishing between DMS and methane is simply beyond the capabilities of NIR spec. But does this mean Webb's capabilities have already been fully exhausted, and we won't be able to uncover the true background to the DMS question? Fortunately not. Researchers emphasize that unequivocal proof is possible because DMS and its breakdown products generate a signature in the mid-infrared range between 9 and 13 micrometer wavelengths, which is exactly where Webb's mid-infrared instrument, MIRI, operates. While the first NASA announcement spoke of a possible detection of dimethyl sulfide, Cambridge scientists wanted more clarity. As a result, astronomers once again used Webb's sharp infrared vision to investigate the mystery of this supposed biosignature. They allocated 8 hours for a targeted search for DMS, and 1 to 2 days later, the research team began evaluating the data. However, such data analysis is laborious and takes months to complete. The good news is that the experts have already been working on the analysis for half a year, so it won't take much longer before the findings on the presence of DMS on K218b are published. Meanwhile, the astronomical community is not condemned to simply wait. They can also approach the DMS question from a theoretical perspective. Scientists, led by Shangmin Tsai of the University of California, Riverside, used models to reconstruct K218b's possible biochemistry, simulating its ocean-covered surface and atmosphere. They tested how much DMS extraterrestrial microbes would need to produce for it to accumulate in the atmosphere to detectable levels, and how quickly it would break down due to radiation. Their study concluded that the current data evaluation is not in vain. Theoretically, biogenic sulfur gases on hydrogen-rich ocean worlds, like K218b, could accumulate to detectable concentrations. However, the big challenge is that this would only happen if the organisms on K218b were extremely prolific. In fact, extraterrestrial DMS production would need to exceed Earth's by a factor of 20 for us to detect it, because most DMS breaks down immediately due to photochemical decomposition from solar radiation. In higher concentrations, a natural protective effect could arise, with degradation products like dimethyl sulfide and methane forming a protective shield around the lower atmospheric regions, preventing further breakdown. Only the future will tell whether this scenario matches reality. What is clear, however, is that unequivocal confirmation of DMS would be a monumental milestone in space exploration. The Cambridge team is diligently analyzing the data, and the lead scientist emphasizes that even one direct detection would revolutionize science. Humanity has pondered for millennia whether other life forms exist, and one confirmed example would end centuries of speculation. Whether the extraterrestrial life breakthrough will be named K218b is uncertain, but no other candidate currently offers such a promising lead in the search for life in space. And the trail of your video search now leads you straight to the subscription button. Feel free to click the thumbs up and subscribe so you never miss a new video from us again.